So in my hands, I have 3 different blades, and I'm not condoning holding and waving random blades in your hand. That's not what this video is about. This is about roll cutting. So within my hand, I have a very cheap blade, I have an expensive blade, and I have a blade that was specifically designed for roll cutting. So to start off, I will first, in the vision system, this is the cheaper end of a blade, and we can first see the face before we do the roll cut. I'll now very quickly show the mid-range blade, and you can see the face and the edge before the cut. And then I will show the roll cutting blade, and we will experiment in this video to see how this edge holds up after a single roll cut. Now, one issue with roll cutting is people typically roll cut over a stainless steel mandrel. I am roll cutting over a glass-filled PTFE mandrel with a stainless steel core, so it does protect the blade a lot more than standard ways of roll cutting, and by far my preferred way of doing a roll cut itself. So for this, I place it into the corresponding hole of my jig, and now we are going to cut through using all 3 different blades. Starting off with the lowest one, place it in, rotate it around, and we have a perfect cut. I am then going to use the mid-range blade, and I've just successfully cut through this second layer. And now for the roll cutting blade. So move my catheter one final time and do the roll cut the whole way throughout, and feel wise they do seem very similar. If I'm to pull it away, I have actually separated this tube into different parts. So we can see the 3 different sections all have been beautifully roll cut. If I place into the vision system itself, you will be able to see all 3 parts are roll cut. But what about the blades? What condition are they currently in? Let's first look at the cheapest blade. We can see that there's some areas that have been cut out every time that it hits the wire. You can see these little dents being taken out of the blade. Will the same happen for the mid-range? So for the mid-range blade, a lot more damage has occurred. This is because this blade is designed to be very sharp to cut through plastic, but the end is tapered so much that it is weak against the metal. Now, what about this guy? This was designed specifically for braid cutting. And if we go down through the blade, there are absolutely no indents that are taking it out of this blade at all, which does suggest it is remarkably well designed for the application that it's used for. So this blade is designed by Jim. It was AccuForge who actually handed me this blade, and I am incredibly impressed. But if this works as well as it just did, this could be a bit of a game changer compared to having to use one blade every time you cut a braid, scrap it, and then take out a brand new blade. So very, very interesting to experiment a little bit more with this, but from a first impression, incredibly well working. For more ideas, follow IDEA.